Earlier, we have looked at how to multiply matrices by a scalar. Now, we will look at what happens when we try to multiply matrices by one another. Okay, you have actually done this before last year in A Maths, so this should just be a revision for you. Okay, so for two matrices A and B, okay, if you have A equals to A, B, C, D, B equals to X, Y, W, Z, okay, you will find that this gives you AB. And how do you actually get the product of AB? Okay, you may find it easier. Okay, just remember whenever you want to get a product AB, okay, divide the first matrix into rows and the second matrix into columns. Then you find that, okay, for the first element, it is really equals to the elements in the row, first row times the elements in the first column. Okay, so this is actually row 1 times column 1. Okay, this second element here is really the elements in the first row times the element in the second column, and this corresponds to the position of the element. Okay, note that this element is in the first row, second column, and you can see the same for the third and the fourth element. Okay, it may be a bit confusing using algebra, so let's use an example to try. Alright, look at the first example here. You are given two matrices P and Q. So to find PQ, first of all, okay, recall, it's easier if I divide the first matrix up into row and the second matrix into column. So PQ, okay, if I use the notation, the first element will be, I'm taking the first row times the first column, which corresponds to, okay, the position of this first element, right? It is in the first row, first column and the first row. Okay, then the second element corresponds to, okay, it's still in the first row, but times the second column. Okay, and this third element here, now it is in the second row, but in the first column. And the last element will be in the second row and the second column. And we go on to work out, okay, what each of these elements are. So looking at the first one, row 1 times column 1. Okay, so we'll focus our attention on the first row and the first column. So what does it mean by taking row 1 times column 1? What you will do is to take the first element of the first row times the first element of the column, and the second element of the first row times the second element of the column, and you add them together. So you will get 6 times 1 plus 5 times 2 for the first element. Okay? So for the second element, alright, we will take the first row times the second column. So remember, I want the first row and the second column. And what do? I will take the first element in the first row, 6, times the first element in the second column, 7, okay, plus 5 times 8. So what I'm doing here is I'm taking 6 times 7 plus 5 times 8. Okay, can you try the third and fourth element by yourself before you check the video again? Okay, for the third element, we want the second row times the first column. So I will highlight the second row times the first column. And looking at the elements inside, it will be 4 times 1 plus 3 times 2. Okay, and finally for the last element, alright, I want the second row and the second column. So if you look at the elements again, it will be 4 times 7, okay, plus 3 times 8. Alright, if you are confused, you may want to pause the video at this point, rewind it again and look through the process again. Okay, and the final step that remains now is really just for us to work out the values. Okay, so you may either use your mental sums or your calculator to work out the values, and you should get the final answer here. Alright, so you may want to review this example again. If not, okay, let's look at another example and then we can try this again. Okay, so remember, okay, now we have matrix. Just now we have matrices of the two of the same size. But now we have matrix with two different sizes. Okay, the first matrix is a 1 by 3 matrix, right? Because this is one row, 3 columns. And the second matrix is a 3 by 2 matrix. It has 3 rows and 2 columns. Now, how do we know what is the size of the final matrix? Okay, it is actually very simple. All you need to do to get the size of the final matrix is just to take, okay, the first and the last number of the order, and we will know that the final matrix will actually be a 1 by 2 matrix. Now then, what is the middle number for? The middle number is just for us to check whether it's possible to multiply the two matrices together. If these two numbers here are different, then it will not be possible for us to multiply the matrices together. Okay, so recall again, the first and the last number tells us the order of the final matrix, whereas the numbers in the middle will help us to determine whether the matrices can be multiplied. So knowing that the final matrix is a 1 by 2 matrix, okay, what would a 1 by 2 matrix look like? It will have one row and 2 columns. So I know it will have one row and 2 columns, okay, so it should look something like this with 2 elements. And what's going to be in these 2 elements here? Okay, the first element will of course be row 1 times column 1, and the second element will be row 1 times column 2. Now let's try to work out what, okay, each of these are. Now row 1 times column 1. Okay, again, it helps if you can split up. Okay, remember, first matrix always in row, second matrix always in columns. So the first element is row 1 times column 1. And if you work that out, you will get 8 times 30. Okay, it's always a plus in between. 10 times 25 plus 7 times 35. So this will be your first element. And the second element, what you will do is you will take, okay, let me just use a different color. Alright, the first row times the second column. Alright, and if you take the first row times the second column using each element, you will get 8 times 35 plus 10 times 24 plus 7 times 30. Okay, I will leave you then to use your calculator to work out what the final two values are. But what is more important is, okay, the steps that is involved. So it is important to note that the number of columns in the first matrix, okay, must be equal to the number of rows in the second matrix. This is the test that I mentioned earlier. You must make sure that the numbers in the middle are equal. And the order of a product of a m times n matrix by a n times n matrix, remember, the middle is the same. Then how do we look for the final size of the matrix? You will take the first times the last. So you will end up with a m by p matrix. Okay, so looking at some of these examples here, you can see that if I have a 1 by 3 times a 3 by 1, okay, taking the first two, of course, after checking through that, okay, it can be multiplied, you will get a 1 by 1 matrix. Second example, again, first of all, check. Okay, middle is the same, means the two matrices can be multiplied. Final size of the matrix will be a 1 by 2 matrix.